we're asked to match the correct equation to the correct graph. Let's first take a look at our notes below. Our textbook defines the standard form for the equation of a parabola as y equals a times the square of x minus h plus k, or x equals a times the square of y minus k plus h. The second equations I've included can also be referred to as the standard form for the equation of a parabola, depending on the source. From my experience, the second equations are more commonly referred to as the standard form for the equation of a parabola, and the first equations are more commonly referred to as the vertex form of a parabola, but I'll go ahead and use the language of our textbook and refer to the first equations as the standard form for the equation of a parabola. Let's first consider y equals a times the square of x minus h plus k. When we have the equation of a parabola in this form, we have a vertical axis of symmetry, which means the parabola either opens up or down. If a is greater than 0 or positive, the parabola opens up. Notice we have a vertical axis of symmetry. If a is negative or less than 0, the parabola opens down. And notice we still have a vertical axis of symmetry. The axis of symmetry is the equation x equals h, and the vertex is the point h comma k. And our text states to find additional points, we would determine the intercepts of the graph. The nice thing about this other form of the equation I included is the absolute value of p indicates the distance from the vertex to the directrix, as well as the vertex to the focus. And now let's consider x equals a times the square of y minus k plus h. When we have the equation in this form, we have a horizontal axis of symmetry. If a is greater than 0 or positive, the parabola opens to the right. Notice we do have a horizontal axis of symmetry. If a is negative or less than 0, the parabola opens to the left. Still a horizontal axis of symmetry. The equation of the axis of symmetry is y equals k, the vertex is h comma k, and again, to find additional points, we would determine the intercepts. But again, using this second equation, the absolute value of p indicates the distance from the vertex to the focus, as well as the vertex to the directrix. So let's write each of the equations in the standard form of a parabola based upon our textbook. Looking at equation 1, because we have the square of y plus 1, or the y part is being squared, we want to write the equation in the form of x equals a times the square of y minus k plus h. Once we have it in this form, the value of a will tell us whether the parabola opens right or left, and then the point h comma k will indicate the vertex. This information should be enough for us to determine the correct graph. Notice to solve the equation for x, we would subtract 2 on both sides, giving us the equation x equals 3 times the square of y plus 1 minus 2. And notice number 2 is almost the same equation, except instead of the parentheses, for number 1 we have y plus 1, for number 2 we have y minus 1. So let's also solve equation 2 for x by again subtracting 2 on both sides, which gives us the equation x equals 3 times the square of y minus 1 minus 2. And now for both equations, because the y part is being squared, we know the parabola has a horizontal axis of symmetry and opens left or right. Because a is positive 3, which is greater than 0, we know both parabolas open to the right. And now to determine the vertex for each parabola. In both cases, the vertex is the point h comma k. For number 1, because we have a minus 2 on the end, actually in both cases we have minus 2 on the end, which indicates h equals negative 2, and therefore in both cases the x-coordinate of the vertex is negative 2. But then for the y-coordinate, which is equal to k, for the first equation, or number 1, because we have y plus 1, which is equivalent to y minus negative 1, k, or the y-coordinate of the vertex, is negative 1. And for the second equation, or number 2, because we have the square of y minus 1, k is positive 1, and the y-coordinate of the vertex is positive 1. So now we're looking for two graphs that open to the right, where one vertex is negative 2 comma negative 1, and the other is negative 2 comma 1. This limits us to graph B and graph D. The vertex on B is the point negative 2 comma negative 1. The vertex on D is negative 2 comma 1. This indicates graph B matches with equation number 1, and graph D matches with equation 2. And now let's take a look at equations 3 and 4. Notice for both equations 3 and 4, the x part is being squared, which indicates we want to write the equations in the form of y equals a times the square of x minus h plus k, and because the x part is being squared, the parabolas will open up or down. Solving number 3 for y, we would add 1 to both sides of the equation, and if we reverse the order of the equation, we would have y equals 3 times the square of x plus 2 plus 1. And then for number 4, notice the equation is already solved for y. Let's go ahead and clear the information from number 1 and number 2. And now focusing on number 3 and number 4, because the x part is being squared, we know the parabola has a vertical axis of symmetry and will open up or down. And for number 3 and number 4, we have a is greater than 0 or positive, which indicates in both cases the parabolas open up. And now let's determine the vertex for number 3 and number 4. The vertex is always h comma k. For number 3, because we have the square of x plus 2, and x plus 2 is equivalent to x minus negative 2, h is negative 2, giving us the x-coordinate of the vertex. And because we have a plus 1 on the end, we know k is positive 1, the y-coordinate is positive 1. For number 4, because we have the square of x minus 2, notice h is positive 2, which is the x-coordinate of the vertex, and k, just like number 3, is equal to positive 1, which is the y-coordinate of the vertex. So for number 3 and number 4, we're looking for parabolas that open up. For number 3, the vertex is negative 2, comma 1. For number 4, the vertex is 2, comma 1. So looking at A and C, for A, the vertex is negative 2, comma 1, and for C, the vertex is 2, comma 1, which indicates equation 3 with a vertex of negative 2, comma 1 matches graph A, and equation 4 matches graph C. I hope you found this helpful.